Hi, welcome to the third video. This one will be concerning uh, material utilization and material blanking tonnage. Basically, for a quoting strip layout, a new project, a new part you guys are quoting on, you need some tonnage to find out if it's going to fit in a press. You want to know what your material usage is. Die Designer has the tools that really helps you do that. Um, what I've already done here is I've created a strip layout based on the part. And just to give you a little bit of the upfront, based on what I've drawn, uh, I've determined the progression at 0.600, a stock width of 0.650. The material thickness is 15 thousandths, punch and die clearance, stripper clearance, not really applicable for this. But anyways, the first thing I wanted to show you how to use is the material utilization, or MU. So I have that data that I just showed you already set. Um, and if it wasn't, you would be able to enter those material parameters here to get that. Now, based on the part, let's scroll down. Let's just call this a 260 brass half hard part. Um, and what we are going to do is next select the part flat blank. So you need to have a flat blank already created and joined into a continuous polyline. And then after I do that, I will select the scrap within the part. So let's click this. I'm going to come down here and I'll select my flat blank. If it was a 2-up, I'd select 2 of these flat blanks, hit enter, and then select the scrap within the part. These are actually dimple holes, so they're not scrap, but these two are pierced holes, so I'm going to select them. And then I'm just going to click OK. And I will be prompted where to put this. And yeah, so it spits out a nice little table with the multiple, the stock width, the specific gravity per cubic inch, based on that half hard 260 brass, your total weight in pounds per thousand, your total part weight in pounds per thousand, your scrap weight, and then your scrap percentage. So yeah, real easy and quick to do that. Now I'll go on to do the uh, blanking tonnage, or TO. So basically the same thing. We're going to stay with this 260 half hard. We got a tensile strength. If you don't find your material on here, you can just look up its tensile strength, put the tensile strength in here. The shear strength defaults to 80% of the tensile, but you can put that into whatever you want to from the drop down list. Once again, the material thickness, the multiple, and the stock width are parameters that are taken from the setting. But anyways, if following the prompt, the first thing you would do is select all holes and cuts. So I'm going to do that. We have 2 pierced holes. These 4 are dimples. This is scrap, this is scrap, this is scrap, and this is scrap. Now, based on that, I don't have to do this outside because that's, well, I could for blanking tonnage, but we're only blanking on these little portions here. So I could trim this up to get that, but I'm not going to for this demonstration. So yeah, so I've selected all my cuts, and now I'm going to just click OK. So my blanking and cutting force, it gives me 2.17 tons. The stripping force is 433 pounds, and that's a 10% calculation of the blanking force, figuring completely enclosed cuts, no open sides, etc. Gives you your total perimeter, your material thickness, and then your tensile strength, and then your shear strength percentage. So yeah, real quick and real easy to help you in your quoting. Certainly you can pretty this up a little bit for your quoting purposes. I will go with a large detail balloon, pop it right there. Let's move it up a little bit. Change the current layer to notes and just start with some text. Start point 125, rotation angle 60, pilot, pierce, and part pierce. Move it. So yeah, I'm going to just quickly list all my working stations here. Dimples, cuts, form, blank and wrap. Now I'm going to edit this. If I could spell right. Cuts. First form up. Finish form. Blank. Scrap. And ramp exit part. Now let's adjust the balloon numbers. Well, I can go up here again. Balloon, increment balloon numbers, BI, increment by 1. And there you go. I'll put a couple dimensions on here. We already have the stock width, but we can show it. Typical. Our perf hole diameter. And yeah, it's starting to look nice now. Let's put, let me see here. Yeah, and that's it. So once again, you got your material utilization. You know your blanking force. Now, certainly this is a thin material, small part, but you know, if you're doing something big and thick, it certainly could become an issue to know what your blanking tonnage, and that is all calculated flat punches with no shear, with no stepping. So, you know, that's maximum. You start putting shear on your punches, you stagger your punches, that cutting blanking force will reduce dramatically. But for calculation purposes, like I said, flat punches all the same height. So yeah, hope you enjoyed this. The next video I do is going to be on bend development, flat blanks, overbends, etc. Thanks for watching.